and a coordinate. So even if I ask for standard form, you should all still get this correct because you're going to know to put it into vertex form, then convert. Correct? Vertex form, then convert. So normally when I give this question, if I have it in vertex form, I know I'll get about 60% of you getting it right. If I ask for it in standard form, it drops substantially because you'll try and put it into standard form. Like if I ask for it in the equation in the form y equals ax squared plus bx plus c, it goes really poorly because you're like, well, I can't put it in vertex form. It's in that form. Not only can you have to put it into vertex form first, then expand to standard. Do you see what I'm saying? There's no way you can put it into that form directly. I get some random numbers. They're never right. Okay? Also, you should be able to walk away knowing you got this right or wrong because you can type it into your y equals. You can change your window to match that one, and the graph should look exactly the same. Right? All right. So we have a vertex. It's at 3, 1. What do we label it? P, Q. We always label it because the moment you label it, you have declined your chances of screwing up substantially. That's why we label. Okay? If not, people will swap the two. They'll swap the point and the vertex, and then they'll get the wrong thing. Okay? We need another coordinate. I want one that crosses through, so I'm going to use 0 and 7. And that's going to be my x and my y. If you use a different coordinate that crossed through, which the other one that you could use that would be okay would be 6 and 7. The rest don't really cross through in spots, so if you're picking them, they're not real. Okay. If there's a bolded one on the test, so if I went and I actually gave you this question on a diploma, they'll bold one of them. Don't be like, I wonder why there's a dot there. A dot's there because you need to use that dot. That's why there's a dot there. Okay? On the diploma, they'll bold a dot because then it forces you to use that one point and you can't guess on something else. Or in the paragraph, they'll say this coordinate is on the graph, like they'll give you a coordinate. Okay? All right. We labeled it x, y, p, q so we don't screw up. We get y equals a, x minus p squared plus q. We get y equals, and I always just put the vertex in first, x minus 3 squared plus 1. And then once I do that, I plug in the x, y. I used to plug them all in at once, and then things went awry. Also, people didn't know what equation to put their a back into. So once you get your a, you're going to put it back into this second filled in one, right? So I plug in my y, I get 7 equals a, 0 minus 3 squared plus 1, subtract 1, 6 equals a times 9, because negative 3 squared is 9, not negative 9. You have to put in brackets. Divide by 9, and a equals 2/3. Am I done? Do I have an equation? No, I have an a. So what's my last step always? Put it back in to the filled in first equation for a. We can get y equals 2/3 x minus 3 squared plus 1. So this is vertex form. Then we have to do the other form. What's it called? Standard form. And you will have to convert from vertex to standard, at least in a question, even if it's not this. Right? Because that's an outcome in your curriculum, and I taught it to you, so it's going to appear on your test somewhere. Every single outcome you get taught, at least one question will be on the test about it. Right? So you're going to have to go from vertex to standard. You're going to have to. It is an outcome. Okay. So vertex form is y equals 2/3, I don't remember what it was, x minus 3 squared plus 1. What did I tell you to do with standard form first? Take the squared and just write it out twice instead, right? So we're going to get y equals 2/3 x minus 3 plus 1. Expand it, we get y equals 2/3 x squared minus 3x minus 3x plus 9 plus 1. And then we can collect like terms we want. So y equals 2/3 x squared minus 6x plus 9 plus 1. I can't do anything with that 1 till the very last step. Remember, I distribute. So we go 2/3 times x is 2/3 x squared. 2/3 x squared. And then 2/3 times negative 6. Everyone should practice typing in their calculator. We're also going to do the actual math. But practice typing it in. So 2/3. Every fraction has to be in what, or your calculator doesn't know it's a fraction. Bracket. So you go 2/3 times negative 6. Off to the side, I'll do math. So we go 2/3 times negative 6. Negative 6 is over 1 because every number is over 1. And when you multiply fractions, you multiply numerator times numerator, denominator times denominator. So you can get negative 12 over 3, which is actually negative 4. Everyone's typing in their calculator, though, to check. So you're going to get negative 4x. So you're going to go 2/3 in brackets times negative 6. Did everyone get negative 4? Yeah. So make sure when you put a fraction in your calculator, it has to be in brackets. Now you're going to go 2/3 times 9 in your calculator. 2/3 in brackets. Everyone's typing it in. Take your calculator, put it in your hand. Type in 2/3 times 9. So we get 2/3 times 9 over 1 is 18 over 3, which is, what should you all be getting in your calculator? 6. Then we have plus 1. So y equals 2/3 x squared minus 4x plus 7. Yes, it's important to be able to do them in your algebraically off to the side, but it's also important to be able to check with your calculator so you know if you're right or wrong, right? You have an expensive calculator, why wouldn't you use it to check? Now, what is my y-intercept? It's the only thing it really gives me. It's 7. Remember that this number at the back, I didn't ask you for this, but we're reminding ourselves, this number at the back here, that's my y-intercept. The constant, the one without a variable, whenever there's no bracket. So it has to be in standard form. People will go in vertex form and give me the back number and say it's the y-intercept. Is the back number of the vertex the y-intercept? No, it's the y of the vertex, correct? So it needs to have no brackets, and then your constant, your number without a variable at the back is the y-intercept. So it's at 0, 7. Then we're going to flip over. So this one, I want you to determine the vertex algebraically. What am I indirectly asking you to do? Put it into vertex form. How do I do that? Complete the square. Yeah. So if I want the vertex algebraically, I'm asking you to complete the square so that you have it in vertex form. When it comes to a test, you have to see a question and be able to complete the whole question without having your notes, because you don't have them, and without having to wait for me, because you won't have me to help you, right? So when you get a question, you have to be able to complete it from the first step to the end step without your notes and without me. Because what does your test have? No notes and no me. If I can ask you, no. No, you can't. Okay? So if you're someone who has to look back to figure out how to do something, or you're like, I wouldn't have known to complete the square, you need to be able to, right? You see vertex, complete the square, get me the vertex form. So this one I set you up with a fraction because I haven't really given you any of those. So we're going to have y equals -2, and then I go square bracket, round bracket. I'm going to take the -2 out of the first two terms. So -2 out of -2, I get x squared. And then 5 divided by -2, I'm not going to use that as a decimal. I'm going to write it as 5 divided by -2. So it's going to be minus 5 over 2, x. So that is actually my b. We agree? My b is a fraction. So how do we get the blank beside it? We take b and divide it by 2 and square it. So we get -5 divided by 2 divided by 2 and square it. Most people will forget the second divided by 2 because it already has a division of 2. So everyone's typing in their calculator. Negative 5 over 2 divided by 2. How do you type that in? Negative 5 over 2 in brackets. Yep. No. Yeah. I don't know who's that one is. I feel like it's someone. Sam, is it yours?
I'll check.
How do you know?
Still no name on it? Oh, no.
Okay. Nope. Now, a little hint to self for all you guys with your calculators is you should be opening up your battery part and you should be using a knife or something safely and scratching your initial in here. Because people will wreck everything else, but they'll forget to open the lid and look in the back. So when they're like, it's not your calculator, and then you're just like, oh, really? L. And then you're like, and then you just take your calculator and you walk off because you have your own calculator. You know what I'm saying? Yeah. Because they can scratch your name out here. They've done it to me before. They're like, that's not your calculator, Mrs. Lepp. And I'm just like, L. And then they're like, all right. And I'm just like,
I haven't changed the batteries.
no. And then I put it down. And then they walk away embarrassed.
How often do you have to change the batteries?
Depends on how many like courses you're in that need it. So like if you're more sciences and stuff, most times if people like buy like a decent battery, they can make it through all high school.
Because I just know like before like finals and stuff, like most teachers will say like change your batteries.
I used to say bring a pack of batteries with you. I wouldn't change them because most people make it to their grade 12 year and then their calculator dies.
Sell them. $20 them
On the battery. Okay.
for that.
Okay, so can you type into your calculator, go negative 5 divided by 2 in brackets, because it's a fraction, right? Divided by 2. What do you get? Math, enter, enter. Press math, enter, enter. It's going to be negative 5 over 4. And why is it? Because really what you're doing is you're going negative 5 divided by 2 over 1. And you can't divide by a fraction, but you can multiply by its reciprocal, which you're taught in junior high, hopefully. I don't know what COVID taught sometimes, but that's okay. So we get negative 5 over 4. So that's why your calculator is getting that answer, right? And then we square that. And you should always get a positive number when you square something, correct? Because when you square 2 positives, you get a positive, because you multiply 2 positives. When you square 2 negatives, you should get a positive, because you just multiply 2 negatives, correct? And so you should get 25 over 16. Because you were taught this in grade 10 last year, you square the top number, square the bottom number. So when you square a negative 5, you get 25. When you square a 4, you get 16. So I'm going to get plus 25 over 16. And then I have to remember 2. Minus 25 over 16, square bracket, and then I add my plus 1 at the back. Yo.
Am I allowed to put decimals in the equation of my answers in fraction?
You should run fractions all the time.
I did all mine in decimal.
Or you should not stay in the dash 1 stream. I'm saying it for the 2 whiners at the back, not you. The 2 who went, oh! No.
Fractions are silly.
Yeah, fractions just don't work.
You have a calculator that turns decimals into fractions at a whim and does all the math for you, and you're whining?
Yeah.
Yeah.
I can't even.
I just always mess it up.
My mom said, can't say anything nice, don't say anything at all. So I'm going to carry on with my math. All right. So we're going to get y equals negative 2. And then we have to go to a bracket and we get x. Now, this is when I told you not to skip steps, because before you could kind of figure out what multiplies to give me 8 and adds to give me 6, let's say. That was something you could do, right? This is a lot harder. What multiplies to give me 25 over 16 and adds to give me negative 5 over 2? You're just like, I don't know. But remember what I tell you could do every single time. You could just, if you don't skip steps, look one back, right? So this is what it's going to be. It's going to be x minus 5 over 4. And if I took x minus 5 over 4 and I actually expanded it, I would get this. Right? And then I have to put a squared. And then what can I not forget to do now? Yes. The negative 2 times the fraction. So I'm going to go negative 2 in my calculator. Everyone's doing this because a lot of you think you know what you're doing, and you come to the test and actually don't know how to use your calculator, since it's the saddest day ever. For you, not as much for me. Slightly sad. So we're going to go to our calculator. Negative 2 times negative 25 over 16. And what your calculator is doing is negative 2 over 1 times negative 25 over 16, which is going to get me negative or positive 50 over 16, which is going to reduce to 25 over 8. And now we have to do 25 over 8 plus 1. Try it out. 25 over 8 plus 1. It's going to be 25 over 8 plus 8 over 8, which is going to be 33 over 8. 25 over 8 plus 1 is 25 over 8 plus 8 over 8. You can't add them without common denominators. So we're going to get negative 2 x minus 5 over 4 squared plus 33 over 8. And then you have your vertex form. What's up? Sam's scared. Why you can't use decimals? Because your answers are going to be in fractions, and the reason why you don't want to get used to always using decimals is because sometimes decimals don't terminate, or people will round them too early, and you're only allowed to round in the very last step of any type of question, only if it asks you to round. Secondly, you have to get used to be able to doing math with fractions, because next year in 30-1, you guys are going to actually have to do fractions with trig functions. So it might be like cos theta times sine theta over tan theta equals, and you have to approve. You have to not only get used to being able to use your calculators for fractions and be happy when you can, because next year there's going to be ones where it's trig functions, where you actually have to use your math. So you multiply by the reciprocal and stuff like that. So that's why off to the side, I'm getting you to use your calculator, but off to the side, we're always doing the real math as well. Calculator, real math. Not that your calculator's not doing real math, but you're just typing it in there and it's doing math for you. Okay? So, we need to give the domain. What's the domain of every single quadratic? Yeah. X and M in the real. Because it's either going concave up for life or concave down for life. Is this one concave up for life or concave down for life? It's down because there's a negative 2, correct? Leading coefficient's negative. Okay, what's my range? Well, I know it's concave down, so I know my range is going to be y such that y is less than or equal to, and what's my y? 33 over 8. Y the vertex. Y yarn. The direction of the opening is concave down. And then I want you to state any transformations. So this is the other thing that we're going to drill home is transformations. So, oh, I did put that in there and didn't put it. Its axis of symmetry is what? X equals 5/4. So transformations. You're going to have stretches, reflections, and translations. Stretches, reflections, translations, which I refer to as CERT. There's way more transformations next year. There's a couple more added on. So we have to get really good at it this year so that next year it's not so bad. So this number in front here, not the negative, the number in front, we talked about this. If the number in front was big, the graph actually narrowed. And if the number was between 0 and 1, it actually got wider, correct? It's called a vertical stretch. The reason why it was getting wider and narrower was not because we were actually stretching it horizontally. It's because we were taking our y values and pulling them up faster, which made it narrower, or we were pulling them down, which made it wider. That's why 0, or between 0 and 1, it made it wider, because you're taking those y values and you're squishing them, so the graph's going to take longer to get there. And the ones where it's 2, you're taking all your y's and you're multiplying them by 2, so you're pulling them up really fast. So if you had 0 and 1, it's now going to be at 0 and 2, so it's going to grow faster. Okay? So this number in front is called a, and you can't short form this, and you can't miss any of these words or it won't work. It's a vertical stretch, and this is used directly next year. Whole big unit on it. Vertical stretch by a factor of 2. We never say -2 because the negative actually caused the graph to go concave up to concave down, correct? That's what the negative does. It doesn't stretch it at all. It just makes it up or down. So this is a vertical stretch by a factor of 2, even though it's a -2, about the x-axis. You might as well memorize it this year so that you have it for next year. So it's a vertical stretch by a factor of 2 about the x-axis. Now, what did the negative in front do? It caused the graph, instead of it being concave up, it's now concave down. Which axis am I reflecting in? I'm up here. I'm now down here. Which axis am I reflecting over? X. So this is a reflection in the x-axis. So when it's negative in front, there's a reflection in the x-axis. So when it's concave down, there's a reflection in the x-axis. If it's concave up, you would have nothing in for R. So if it was like a positive 2, you'd have a vertical stretch by a factor of 2 about the x-axis, and then your reflection would just be blank. There wouldn't be one. So there doesn't have to be a reflection. There just happens to be one on this one. And then the translations you guys are good with. So we have 5/4, but it's a positive 5/4, right? Which way did this one move? Left or right? It always moved the opposite. So what's it moving? It's x minus 5/4, so it's actually moving right because it's a positive 5/4. Right? When we take it out, it becomes a positive 5/4. So that's called a horizontal translation. And why is it horizontal? Because it moves left to right. Horizontal translation. 5/4 units right. What do you think the other one is? Not a horizontal, but a vertical translation. 33/8, up or down? It's up. Because remember the Q, you just take what it is. The P, you take the opposite of. So it would be a vertical translation. (33/8) units up. Then these ones, I wanted you to determine the x-intercepts, roots, zeros of the following algebraically and check graphically. What's the first thing we have to do in order to be able to solve these? Set them equal to 0, and then try factoring, right? These ones you could factor because I only taught quadratic formula, and that was after this quiz, so these both have to be factorable. So we're going to have 4x squared minus 4x minus 3 equals 0. And then I say what times what equals -12. What plus what equals -4. What's it going to be? -6 and positive 2. Now I have to do decomp because there's a number in front of here. So I replace that. So I'm going to get 4x squared minus 6x plus 2x minus 3 equals 0. And then I group. I can take a 2x out, and I'm left with 2x minus 3. What do I have to take out of the back bracket to make it the same? A plus? Just plus 1, right? Because there's nothing to take out. So I get 2x plus 1, and 2x minus 3 equals 0. What's my, so that's grade 10. I've done nothing but grade 10. What's my grade 11 step? Take those two and set them equal to 0 and solve, right? So I'm going to get 2x plus 1 equals 0. 2x minus 3 equals 0. 2x equals negative 1. Divide by 2. X equals negative a half. Add 3. 2x equals 3. Divide by 2. X equals 3 halves. Now, on the bottom half below this, you're going to solve this using the quadratic formula. Go. You're going to use the quadratic formula. So this is your A, this is your B, this is your C, and you're going to use this. So we have x equals negative a negative 4. What happens when I get minus a minus 4? It actually turns plus, right? Then we get plus or minus negative 4 squared minus 4 times negative 3. The entire numerator over 2 times 4. So we're going to get x equals 4 plus or minus, and then I told you to do the what's in the bracket, right? So you're going to get, oh goodness, 16, and then 16 times 3 is 48, it's 58, 64, under here, over 8, and then we get x equals 4 plus or minus 8 over 8, because the square root of 64 is just 8. We agree? Yep. Yeah. So then at this point we split it. We're going to get x equals 4 plus 8 divided by 8, which is 12 over 8, which I can take a 4 out of both. So I get 3 over 2. Matches. And then I get x equals 4 minus 8 over 8, which is negative 4 over 8, which is negative a half. And it matches. Now, will quadratic formula always work? Quadratic formula will always work unless I say solve by factoring and you use quadratic formula, then you get no marks because you didn't actually do it the way I asked, right? But quadratic formula will always get you the right answer. Can you always solve by factoring? No, you can only solve by factoring if the equation can be factored, correct? So quadratic formula always works. So if I say algebraically and I don't pick a method, you could do either and give me the correct answer, right? All right, it's faster to factor often if you're good at factoring. Okay, let's go to this one. So we have to add the 4x and add the 3 over first because we need it equal to 0. And I always move it to the x squared. So I'm going to get x squared plus 4x plus 3. This one's way faster than using the quadratic formula to factor it because it's just product sum, right? So it's what times what gets me 3. And then what plus what equals 4. So it's 3 and 1. So I get x plus 1, x plus 3, or x plus 3, x plus 1, it doesn't matter. And then I just go x plus 1 equals 0, x plus 3 equals 0, subtract 1, x equals negative 1, subtract 3, x equals negative 3. What do you think I'm going to ask you to do? Quadratic formula. Go. Solving that one with the quadratic formula. What number's in front of the x squared if there's no number there? It's a 1, not a 0. If it was a 0, it would cancel the x squared right off. Quadratic formula, go. So, this is A, this is B, this is C. We get x equals negative B, which is 4, plus or minus 4 squared, minus 4 times A times C, all over 2 times A. x equals negative 4 plus or minus the square root of 16 minus 12, which is 4, over 2. So x equals negative 4 plus or minus 2 over 2, and then it splits. Now, if your answer that you found was a nice solid answer, your square root on the quadratic formula will turn out to a nice number, like 7, 5. It could be a perfect square, right? So this is good. So we're going to get x equals negative 4 plus or minus plus 2. Oh, crud. Why you hate me. Okay. 4 plus 2 divided by 2, which is negative 2 divided by 2, which is negative 1, which is one of the answers. And then I get x equals negative 4 minus 2 divided by 2, which is negative 6 divided by 2, which is negative 3, which is the other answer. So I just guaranteed that it works. Now you have to take out some paper because we're going to do discriminant. 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 Nature of the roots. Discriminant. Nature of the roots.
Wow, I can't believe we live in society.
I don't know what's going on. Okay, it's probably safer that way. So we're going to talk about the discriminant. And the nature of the roots. First, we're going to do a little bit of a discovery. Ooh. Fun.
What?
All right. So it's a little discovery. Here's example 1. Shh. Example 1, I want you to solve. So when I ask you to solve, you have 2 ways you can try. Factoring or quadratic formula. Today's, I'm going to force you to solve them all by quadratic formula because we're doing a discovery with the quadratic formula. Okay? So here's your first one. Y equals 2x squared plus 12x plus 14. So I want you to solve it. So if it's not in 0 equals, we would have to have it in 0 equals. Why can't we just turn the y into a 0? When we're asked to solve, what are we finding? The x-intercepts, which means y is 0, right? I want you to solve this using the quadratic formula. Here's your quadratic formula, just in case you forget. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So, we have, this is my a, this is my b, this is my c, and I use the signs in front to fill it in, correct? Now, what you need to know is how to do the quadratic formula really well. It is used a lot in 30-1. If you're like, no, I'm not lying. I teach it a lot. It is used a lot. So what happens is we'll do trig or we'll do other things. And then what happens is people will be able to do the 30-1 material and then they get to this and they can't do this. That's terrible. Like, it's not good for you if that's where you get stuck, right? In the previous material that you've learned. We don't want you to be there. We want you to be able to just get to here and be like, boom, I got this. I've learned it. I know how to do it really well. Right? Okay. So we're going to get x equals minus b. b is 12. Plus or minus the square root of b, which is 12 squared, minus 4 times 2 times 14, all over the entire numerator, 2 times a, which is 2. So then I'm going to get x equals negative 12 plus or minus the square root of. Then I told you, type into your calculator exactly like this without the root. So you go 12 squared minus 4 times 2 times 14, and you get 32. Right, Ted? That's what you said?
Yeah.
32. And then it's over 4. Then This is all new. This is all grade 11. Everything we've done so far, all grade 11, correct? Where do people often get their marks lost? The grade 10 reducing of a radical. So you have to stop the vicious cycle of every single year you're getting into trouble because of the previous year's math, right? We want to know this year's math so well with the previous year's math that when we get into grade 12, it's like, I can do all of this, I just have to learn the 12. It's not like you want to learn the 12 and then have to relearn your 10 and 11 because you didn't learn it well enough. Okay? That's why anyone with below a 75 in 11 often doesn't do so great in grade 12 because we have to end all of our grade 12 stuff with 10 and 11 material. And it's just going to get you every single time. Okay? So we have to have as high of a mark and know stuff as best as we can going into 12. So off to the side, I go do my grade 10. I say, okay, root 32. I was taught in grade 10 the only way I could take something out of a square root is if it was a perfect square. So if it was a 4, or it was a 9, or it was a 16, or a 25, or a 36, or a 49, then I could take it out, correct? Some people will tell me 8 times 4. And 8 times 4 would work, but I'm just going to have to go again, is what's going to happen. So I always try and take out the biggest perfect square I can. And so 32 breaks into 16 and 2. So I write 16 times 2. Now the reason why I picked that is 16 is the biggest perfect square. And so I can't take the 2 out. The 2 will never be able to come out, right? There's no perfect square version of 2 that's going to be able to pull out. So that root 2 is going to stay for life. That's never going away. And in the quadratic formula, it's never going away. I won't be able to cancel it off. I won't be able to cross it off. That root 2 staying for life in my answer of my quadratic formula. Okay? Not going anywhere, can't cross it off. Do we understand? But the 16 I can take out because the square root of 16 is 4. And if I'm taking the 16 and I'm trying to pull it out of here, I'm actually taking the root of it to pull it out, to get it out here. So it's a 4. And the 16 goes away and I'm left with 4 root 2. And like I said, my answer will have a root 2 no matter what. Because I can't get that to reduce. Some people are like, well, I could just cancel it off with something else. You can't. That root 2 staying for life. Okay? So we're going to get, instead of root 32, I'm going to take that. I'm going to put it in my hand. I'm going to toss it behind my head. I'm going to take the 4 root 2 and I'm going to put it in its spot. That's all we're doing. 4 root 2 is just the same as root 32. If you don't believe me, type root 32 into your calculator. You should have been able to check these, every single one of them last year with your calculator. If you go root 32, you're going to get a decimal. We agree? Now go 4 root 2 into your calculator. The decimals should match because they are the same answer. One's just in reduced radical form and one is not. Correct? So that's why I can take this root 32, I can toss it out, and I'm going to go negative 12 plus or minus 4 root 2 over 4. Then I have the triangle of numbers, the 3 numbers, correct? If I can take it out of the 3 numbers, I can take it out. If I can't take it out of the 3 numbers, I'm done. I box it, I move on. That's exact values. Okay? So, I can take a 4 out of all 3 of these. And when I take out a 4, I'm actually doing division. Negative 12 divided by 4 is negative 3. 4 divided by 4 is a 1. 4 divided by 4 is a 1. Do I need to write a 1 if it's in the denominator and that's all that's left? No, every number is over 1. Like 7, the number 7. I love the number 7. It's over 1. Do I write the 1? No. If it's 1/7, can I just ditch the 1 off 1/7? No, because now it's 7 and 1/7 doesn't equal 7, correct? So when you have a 1 just sitting in your numerator, that baby has to stay because it makes it a fraction, correct? But if you have a 1 in your denominator, do I have to write it as 7 over 1 for life? No, I can just write it as 7, correct? So if there's just a 1 left in your denominator, it can take a hike. Oh. It's everywhere. You can grab a paper towel and you can clean yourself first and then clean up the rest of you. Yeah, can you Tristan or Hannah, can you grab her some? I didn't realize it was, you had it on your lap too. It's everywhere. X equals negative 3 plus or minus root 2. Okay. If it was exact values, I'd stop there. How many solutions would I get? You're going to get 2, correct? Are we not? Because whenever we have something under this radical, we would technically get 2 solutions. We're going to get an x equals negative 3 plus root 2, And we're going to get x equals negative 3 minus root 2. And I don't go any further unless they ask for it in decimals. Which, if they ask for an exact value, I'm done. But I got 2 solutions for that one, didn't I? Do you agree? Yeah.
For the exact value, is it one box or both? Like,
Either one. Both are equivalent. Yeah, you could either list them both out separately and do 2 boxes, or you could leave it together and put 1 box. That's the same answer. Okay. We're going to try example 2 now. And then we'll come back and we'll discover what we're learning here. So example 2, I want you to solve this one. Where did my sheet? Okay, you're going to try this one now. Y equals, or I'll say 0 equals, we don't need y. 0 equals 3x squared plus 12x plus 12. I want you to solve this one with the quadratic formula as well. You could actually solve some by factoring, but I do not want you to do that because we're discovering the quadratic formula, the discriminant in nature of roots. So I want you to solve it with the quadratic formula. So we have A, B, C, and we're going to get x equals negative 12 plus or minus the square root of 12 squared minus 4 times 3 times 12 all over 2 times 3. So we actually get x equals negative 12 plus or minus the square root of what? What did I set you up for? 0. What happens when I add a 0 and I subtract a 0? You get 0. Does it do anything different? No. So when that under that square root is a 0, how many solutions am I going to have? 1, technically, right? I'm going to have 1. You actually have 2. They're the exact same. But you tend to get 2 solutions. They're just the exact same, right? So you're going to get negative 12 over 6, which is negative 2. So x equals negative 2 is my solution. We agree? So when I had a number under that square root, I got 2. 2 totally different solutions, didn't I? Look, when I had root 2, or root 32, technically, I got 2 totally different solutions, correct? When I have root 0, when I add a 0 and I subtract a 0, I get the same one, correct? Now everyone type this into your calculator. Go to y equals, type this one in. Y equals 3x squared plus 12x plus 12. 3x squared plus 12x plus 12. And then zoom 6 just in case you have a weird window going on there. What's happening? What are you seeing in front of your face? I have a trig graph. So.
See a graph.
A graph?
The vertex is
The vertex is where? On. It's on the x-axis, isn't it? The vertex is the x-intercept, is it not? So when you get square root of 0, your vertex is on your x-axis. And you get the square root of 0. Because you get the same solution twice. The only way you can get the same solution twice is if your vertex is on there. Because if your vertex isn't on there, you're going to get how many solutions? 2. If your vertex is on there, you're going to get 1. Okay, let's talk about the last option we could have. You're going to try this one. Example. Ooh, that's... Okay. Example 3. So you're going to try y equals negative 2x squared plus 16x minus 35, and I want you to solve it. So you're going to turn your y into a 0. I want you to use the quadratic formula for this one as well. You couldn't factor it even if you wanted to. So this one I'm going to get x equals minus 16, or negative 16, plus or minus 16 squared minus 4 times negative 2 times negative 35 all over 2 times negative 2. So I get x equals negative 16 plus or minus a negative something. What do I get? Negative 24? The moment I get a negative under a square root, what happens? Got problems. Okay, it's impossible. So you're going to get, the moment you get this, what did we tell that what's going to happen? When we get this, we have how many solutions?
0.
Yeah, none. So we have no solution. So guys, if I ask you for the number of solutions or to show me the number of solutions, would you have to do the entire quadratic formula to tell me if there's no solution, one solution, or two solutions? Would you have to do the whole formula? Did I care what was in the front of that radical or in the denominator? Did I care if I wanted to know just the number of solutions? No. If I want the actual solution, I have to do the whole quadratic formula. We agree? But if I want the number of solutions, what do I only care about? What's under that radical, correct? That's all I care about. So if I have x equals negative b plus or minus the square root over 2a, I really only care about this. Why? If that was greater than 0, what happened? How many solutions did I get? I got 2 solutions, correct? This is b squared minus 4ac, is it not? That's all that's under there, isn't it? So that circle is actually b squared minus 4ac. We agree? So if I just figure that out and it's greater than 0, you can tell me what? There's 2 solutions. We agree? Then, if you figure it out, b squared minus 4ac, and you find out it equals 0, so there's a 0 under this radical now, how many solutions would I have? Just 1, right? If there's a 0 here, if I add 0 or subtract 0, does it change my answer? No. So if b squared minus 4ac is equal to 0, I have 1 solution. And what happens if under this radical, which I just did, it's negative? What happens when I have b squared minus 4ac is less than 0? How many solutions do I have? No solutions, because I can't take the square root of a negative number, right? The discriminant, which I said up top, the discriminant is b squared minus 4ac. These are the same thing. So if I ask you what's the discriminant, you just give me b squared minus 4ac, fill it in, give me an answer. And that answer can tell me how many solutions really quickly, correct? So to solidify it, say I give you 2x squared minus 4x plus 7, and I want to know how many solutions. Do I have to do the entire quadratic formula if I just ask for the solution? If I ask you for what the solutions are, or I say solve, you have to do the whole shabozzle, correct? But if I just say how many solutions there are, we're just literally doing b squared minus 4ac. A, B, C. And I'm just plugging it in and seeing. If it's greater than 0, I have 2. If it's equal to 0, I have 1. If it's negative, it ain't going to work because I can't take the square root of a negative number, right? So I'm going to do negative 4 squared minus 4 times 2 times 7. I immediately see this is going to be negative just because this is bigger than this. So I get 16 minus 56, which is negative 40. How many solutions am I going to have if that negative 40 is sitting under a square root symbol, which is what it's doing, if I do the whole quadratic formula? I'm going to have no solutions. right? So, you have a little tiny thing on this. So number 2 is what we're going to do from yesterday's homework. It says this. It says, without graphing, determine the number of zeros. What's a zero?
X.
An x-intercept, a root, zeros, all the same thing. So what am I asking for? How many solutions are there? 0, 1, or 2? So are you going to use the whole quadratic formula for this number 2 question that I'm assigning tonight? No, you're going to use B squared minus, you're going to use the discriminant. And if it's positive, there's 2. If it's 0, there's 1. If it's negative, there's none, because you can't take the square root of a negative number. Does that make more sense? So it's just page 254 from yesterday, number 2. Now there are a few parts. There's A to F. However, all you have to fill it into is B squared minus 4AC. That's it, right? If you're filling into the whole thing, you're doing way more work than you need to.